তারপরে তো হ্যালো ছাত্রছাত্রী, কেমন আছো? আশা করি সবাই ভালো আছো, সবাই পড়াশোনা করছো। আজকে আমাদের ইনস্টিটিউট থেকে চলে এসেছি। আজকে তোমাদের একটা খুব ইম্পর্ট্যান্ট ওষুধ পড়াবো এবং এটা অনেকটা নিউলি ডিসকভার্ড ড্রাগস বাট ভেরি ইফেক্টিভ ড্রাগস ইন দ্য ট্রিটমেন্ট অফ কার্ডিওভাস্কুলার প্রবলেমস অ্যান্ড renal problems and other problems also. Actually, our topics, today's topic is mainly Neprilysin inhibitors. So first I will discuss what are the Neprilysin inhibitors. Second I will discuss what are the how they work. That means what are the pharmacodynamics of that particular drugs, and what are the indications, side effects, contraindications, etc., etc. But before that, actually I will discuss about the natriuretic peptide, In short, it is called NP. So natriuretic peptide, basically a group of peptides. Natriuretic peptide basically are a group of peptides. So natriuretic peptide is a group of peptides which are synthesized mainly in different organs. They are synthesized in the atrium of the heart. They are synthesized in the atrium of the heart, in the brain, in the blood vessel, and in the tubular part of the nephron. Tubular part of tubular part, no? That is nephron. Mostly the place of synthesis are atrium of the heart. So what are the natriuretic peptide? Natriuretic peptide is a group of protein-like substances which are synthesized in different origin of your body. Mainly they are synthesized inside your heart, but also they are synthesized in the blood vessel, in the kidney, in the brain, and other tissues. So the main place of synthesis of natriuretic peptide is atrium of the heart. First I will discuss why it is called natriuretic peptide. Natri, there are three terms. One is natri, one is uretic, one is peptide. So let's analysis these all three terms. So first term is natri. Natri is always related to the sodium. বাবু যাবি নাকি? যা, বড় বিড়াল বসে আছে দেখো, ছটপট করে যাবি যাচ্ছে না, দাঁড়াও একটু কাজ করছি। So natri is always related to the sodium. Uretic means uresis. Uresis. What is uresis? Uresis means urination. Uresis means urination or urinary excretion. So when there is sodium excretion through the urine, that event is called natriuresis. So what is natriuresis? Natriuresis means sodium excretion through the urine. So when sodium is excreted through the urine, that is called natriuresis. Exactly, natriuresis is very important because natriuresis is also related with the diuresis. Natriuresis also related with the diuresis. That means when there is natriuresis, there is also diuresis. When there is natriuresis, there is also diuresis. That means diuresis and natriuresis are more or less similar. In case of diuresis, all the substances are including water are excreted through the urine, but in case of the natriuresis, we are mainly giving importance to the sodium excretion. So that's why it is called the natriuresis. So those peptides or peptide like substance, what are the peptides? Mainly peptides are the chain of amino acids. Chain of amino acid. These are all amino acids. And when the chain of amino acid, the number of amino acid in any chain is less than 100, when the number of amino acid in any chain is less than 100, that is called polypeptide or peptides. But when the number of amino acid in any chain is more than 100, that is called protein. So peptides, here they are a group of amino acids which are mainly responsible for the powerful sodium excretion through the urine. So what is natriuretic peptide? Natriuretic peptide are a group of amino acids, group of chained amino acids or group of peptides which are mainly responsible for the excretion of the sodium through your urine. So they are called the natriuretic peptide. In our body there are lots of natriuretic peptides present, but we normally give importance to three particular natriuretic peptides, and those are mainly endogenous. What are the endogenous? Basically they are automatically produced into our body in the cellular level. So they are called the endogenous production. So these three endogenous natriuretic peptides are arterial natriuretic peptide, brain natriuretic peptide and C-natriuretic peptide. Atrial natriuretic peptide is in short is called ANP. Brain natriuretic peptide in short is called BNP, and this is CNP. All the natriuretic peptide acts like the hormone. All the natriuretic peptide acts like the hormone. They also act through second messenger system. So they can be considered hormone like substance, and they are mainly synthesized in the wall of your heart, in the wall of your blood vessel, and in the wall of your nephronal structures. So atrial natriuretic peptide and brain natriuretic peptide, they both are synthesized in the atrium of the heart. Suppose this is your heart, and these are the atrium of the heart. This is the right atrium, this is the left atrium. Mostly they are most sensitive to the left atrium. They are synthesized in response to the mechanical stretch of the atrial muscle. Look here. Suppose this is the normal atrium of your heart. Suppose this is the normal atrium of your heart, and here is this is your right atrium, this is your right ventricle. Everyone, you know, this is the left atrium, this is the left ventricle, and here is your tricuspid valve. And here is your bicuspid valve. You know, the tricuspid valve is also known as right atrioventricular valve, and the bicuspid valve is also known as left atrioventricular valve. Not only that, this right ventricle also connected. This right ventricle also connected with the just functional diagram. This right ventricle also connected with the pulmonary arterial trunk, and here it is your pulmonary valve. Here it is your pulmonary valve. Here it is your pulmonary valve, and the left ventricle is also connected with the aortic system. So outlet of the left ventricle So outlet of the left ventricle or outflow is connected with the aortic valve. So what is the basic function of the heart? The basic function of the heart is to pump blood all over the body, nothing more than that. So heart is the pumping machine, muscular pumping machine. But when heart cannot perform its own action in the full range, when the heart cannot perform its own action in the full range, that is called heart is doing hypofunction. In the normal heart, the cardiac output, in the normal physiological condition, the heart is contracting and the heart is ejecting the blood, and this ejection is called cardiac output. This ejection is called, this is the cardiac output. This ejection is called cardiac output. This ejection is called cardiac output. In case of male and female, we can take the average value liter per minute. In case of the female, is slightly lower, or in case of the male, is slightly higher. So this is the normal cardiac output in case of the normal resting condition. But if there is any pathology, if there is any pathologic change or any physiologic demand, so if there is demand for cardiac output is very, very high, and your heart is not matching that demand. So if there be any circumstances, maybe physiological, often pathological, demand is very high. Suppose you are running up a 3-storied building, you are running upstairs. So suppose this is your friend, beautiful friend, this is your beautiful friend. This is your beautiful friend and he is running upstairs. This is your beautiful friend and he is running upstairs. When he is running upstairs, normally his skeletal muscle, when this beautiful friend, your beautiful friend is running upstairs, his skeletal muscle requires more oxygen. His skeletal muscle requires more blood supply, more oxygen, more nutrients. So these are the skeletal muscle, these are the skeletal muscle, these are the skeletal muscle. So his skeletal muscles require more nutrients, more oxygen. So they require more nutrients and more oxygen. Now how this more amount of nutrients and more oxygen will be reaching there? Now through increased blood supply. That means the blood supply to this muscle should be increased. How to increase the blood supply? Now your heart output should be increased. So your heart cardiac output should be increased. So this is the increased condition. So demand. This is the increased demand for cardiac output. This is the increased, this situation is the increased demand for cardiac output. Suppose this beautiful friend, this beautiful friend had severe anemia. So this beautiful friend has anemia. So when there is anemia, normally the tissue is getting less blood supply. When there is anemia, the tissue is getting less oxygen supply. So tissue is getting less oxygen supply. So when your tissue is getting less oxygen supply, normally your tissue will be requiring more oxygen. Your tissue will be requiring more oxygen because I am getting less oxygen, so I require more oxygen. So here oxygen demand will be increased. Oxygen demand will be increased. And when the oxygen demand will be increased, normally cardiac output should be increased because oxygen will be supplied either through the bounded form or in the dissolved form, mainly bounded form in the blood. So cardiac output should be increased. So there is also the increased demand of the cardiac output. Demand. But in this condition, output demand is very high, but your heart cannot meet this demand. Your heart cannot meet this demand. Suppose now the demand is 5.3 liter per minute for this friend. But his heart, his beautiful heart, is pumping only 2 liter per minute. But his beautiful heart is pumping only 2 liter per minute. So he requires 5.3 liter, but his heart pumping only 2 liter. That means there is a great deficit in the cardiac output. This condition is called heart failure. This condition is called heart failure. That means the output is not optimal. The output is low. Actually, our heart failure topics will be discussed in the future videos, more details clinically. But now that not, I am just simply discussing. So this friend requires 5.3 liter per minute, but his heart is supplying only 2 liter per minute. That means this is the mismatch between the demand and the supply. So there is the mismatch. Suppose in this case there is the mismatch. Suppose in the normal condition, supply CO supply means cardiac output supply should be balanced with the cardiac output demand. In the normal situation, cardiac output supply should be balanced with the cardiac output demand. But in this case, in this friend's case, what is the figure? And the figure is that is the cardiac output supply and that is the cardiac output demand. That means here demand is more but supply is less. So here demand is more and supply is less. So when demand is more and the supply is less, that is called low function or hypofunction. So this is also cardiac output failure. This is also cardiac output failure. In this case, look here, when the this friend is running upstairs, normally the same thing occurs. The demand is more, supply is less, and there is also low function or cardiac output failure. But if there be any pathology in your heart or other organs, those pathologies are mainly responsible for this failure. In normal body, there is no such problem, but in problemed body, there is such problems. I will not go into the details of heart failure, etiologies or pathophysiologies. But my topic is today neprilysin inhibitors. So natriuretic peptide is activated in the time of the heart failure. Look here. Suppose the heart is not throwing enough output, the heart is not throwing optimal output. In the normal case, this heart will pump out how much blood? 5 liters per minute. But now this problem heart is pumping only 2 liters per minute. That means there is a possibility, there is a strongest possibility for this 3 liter blood to get accumulated within the heart. Suppose this is a bucket and this bucket contains this bucket contains 2 liter water. This bucket contains 2 liter water. Suppose this is the bucket. This bucket has a capacity of 2 liter water. So when you turn down the bucket, how much liter will be coming out? Exactly 2 liter. So this is the normal bucket. This is the case number 1. Now consider the case number 2. The same bucket I am taking, and it has the capacity of the 2 liter water. It has the capacity of 2 liter water. It has the capacity. 1 minute. It has the capacity of 2 liter water. But now I am turning down the bucket. But I am observing that only 1 liter water coming out. Only 1 liter water coming out. So rest of the water obviously are getting accumulated within the bucket. So rest of the water, 1 liter, obviously is getting accumulated within this bucket. So in the normal bucket, the normal capacity of this bucket is 2 liter. So naturally it contains the 2 liter of the water. And when I am turning over, normally all the water is coming out. And what is the volume of that water? Exactly 2 liter. But in the second scenario, the same bucket, when I am turning over, only 1 liter is coming out. So only 1 liter is coming out. So when only 1 liter is coming out, then how much water is expected to be accumulated within that bucket? That is exactly 1 liter. So that 1 liter is getting accumulated here. They are not coming out. So in this case, the output is 2 liter, and that is very optimal, expected. But in this case, the output is 1 liter, and that is not optimal or expected. Actually, we are expecting exactly 2 liter coming out in the second scenario also. But in the second scenario, it is different from the first scenario, because in the second scenario, only 1 liter is output, and rest of the 1 liter is getting accumulated. তার মানে আমি যখন বালতিতে জল নিচ্ছি, তখন বালতিতে 2 লিটার জল ছিল, আমি যদি বালতিটাকে উবুর করে দিই তাহলে 2 লিটার জলে বেরিয়ে আসবে। বাট আমি দ্বিতীয় ক্ষেত্রে সেই একই বালতি নিয়েছি, বাট আমি যখন তাকে উবুর করছি তখন দেখতে পাচ্ছি মাত্র 1 লিটার জল বেরাচ্ছে, বাকি 1 লিটার জল জমে থাকছে। সো দ্যাটস নট দ্য এক্সপেক্টেড সিনারিও। আমরা চেয়েছিলাম কি এক্ষেত্রেও কিন্তু 2 লিটার জল বেরিয়ে আসা উচিত ছিল। তার মানে এক্ষেত্রে আউটপুটটা নর্মালের থেকে কমে গেছে, তার মানে সাব অপটিমাল আউটপুট। তো এক্ষেত্রে আউটপুটটা কিন্তু সাব অপটিমাল আউটপুট। এক্ষেত্রে আউটপুটটা কিন্তু সাব অপটিমাল আউটপুট। তাহলে যদি if this 1 liter is getting accumulated within this bucket, normally this water is giving pressure upon the inside wall, upon the inner wall of the bucket. Suppose this is the bucket, and when 1 liter water is getting standing here, when 1 liter water is getting standing within this bucket, normally those standing water are giving pressure upon the inner wall of the bucket. Those standing water is giving pressure upon the inner wall of the bucket. That is called hydrostatic pressure. Hydrostatic pressure. That is called hydrostatic pressure. So similar case is occurring within your heart. Look here, suppose this bucket contains 5 liter blood. Suppose more than 5 liter, but I'm just for easy calculation or easy understanding, I'm rounding off this figure, that is 5 liter blood. So in normal subject, in physiological condition, when the heart pumps, all the 5 liter blood will be coming out. So in that case, the cardiac output will be exactly 5 liter. But in pathological condition, due to pump failure or due to other problem, the heart cannot pump the entire 5 liter. Suppose now the heart is pumping only 2 liter. Only 2 liter. So now the 3 liter of blood, 3 liter of blood is getting accumulated within the heart. Now the 3 liter of the blood is getting accumulated with the heart. So here the cardiac output is lower than the first case. So here heart is having pump failure. Here heart is having pump failure. So in this case, when the water is accumulated inside the bucket, normally it will give strong hydrostatic pressure onto the inner wall of the bucket. So here also, when blood is accumulated within your heart, the blood will giving strong hydrostatic pressure onto the inner wall, onto the inner wall, onto the inner wall, onto the inner wall of the chambers of the heart, onto the inner wall of the chambers of the heart. Suppose this is the single chamber, just forget. This is the single chamber. And when the heart has accumulated blood within it, when your heart has more accumulated blood within your heart, normally this accumulated blood will give the more hydrostatic pressure, onto the inner side of the wall of the heart, onto the inner side of the wall of the heart. Suppose suppose this is your heart. I am just giving, forgot all the separation. So your heart is getting blood accumulated within it. Your heart is getting blood accumulated within it. So when more blood will be accumulated within it, normally those blood will give the hydrostatic pressure. Those blood will give hydrostatic pressure onto the inner wall, onto the inner wall This is the inner wall. They are giving the pressure. Onto the inner wall of the heart. Onto the inner wall of the heart. So when there is constant pressure, when there is constant pressure onto the inner wall of the heart, you know from your basic physics, Newton's third law, every action there is an equal and opposite reaction. So when blood is giving pressure, upon the inner wall of the heart is also giving the equal pressure onto the blood. The heart is trying to give the equal amount of pressure onto the blood. So there are two simultaneous function is going on. Look, this is the condition of your heart. The normal capacity of the heart was 5 liters. The normal capacity of the heart was 5 liters. Now your heart has some pathological condition, and due to that particular pathological condition, your heart output is reduced. And now your heart is giving output only 2 liters. Suppose. So when your heart is giving output maybe lower, so heart is functioning. So when the heart is functioning, normally heart muscle is more working. মানে কি বললাম, ধরো নর্মাল হার্টে কোনো সমস্যা নেই, নর্মাল হার্টে একটাই মাত্র হার্ট কাজ করছে কি, হার্ট ইজ ওয়ার্কিং, মাসেল ইজ ফাংশনিং। তাহলে ইন আওয়ার নর্মাল কন্ডিশন heart is working and muscle is functioning. But here muscle has to perform dual function and very strenuous function. First function, for ejection of the 2 liters of the blood, the heart muscle is working. And second function is that to counteract this hydrostatic pressure, increasing hydrostatic pressure, heart muscle has to give back the same amount of the hydrostatic pressure. That means here heart is contracting for ejection, and second heart is counteracting this increasing hydrostatic pressure. In both cases, so here are two strenuous function. One is heart is contracting to eject blood. That is the first case. And second case, heart is counteracting that ever increasing hydrostatic pressure of blood within the chamber. within the chamber. In both cases, in the normal case there is no such strenuous action. In the normal subject, heart is functioning in two cases, but there is no such strain, no such stress in the normal physiological case. But in the pathological case, both functions of the heart is very strenuous. That means in every cases, in both 1 and 2 number cases, heart has to work against a greater resistance. Heart has to work against a greater resistance or impedance. Suppose this is my marker and this is the, actually I am not capable of raising my left hand because due to shoulder injury. So suppose this is my marker and I am trying as per I can. This is my marker and this is the cap of my marker. When I am opening the cap, there is normal resistance. So I can easily open my cap, marker's cap. But when there is much more resistance, I cannot easily open. I have to give much more pressure to open this cap. So in the second case, I have to spend my extra calorie. But in the first case, that is very normal. But in the second case, I have to pay extra money, extra dollar. So I have to pay extra calorie because there is increased resistance. So I cannot open my yes. So extra calorie. So in the first case, there is no spending of extra calorie. In the second case, there is spending of lots of extra calorie. So in these two cases also, since there is increased resistance due to any pathological condition, in both cases heart has to spend much more effort or much more extra calorie. Heart has to spend much more extra calorie. And that scenario, this scenario is going on day by day. One day will come when heart will leave its function, because heart muscle is always working against a very higher load. In these two cases, heart muscle, heart muscle is working against a higher load. Suppose this is the load you are giving to your heart, and this is the cardiac energy. So heart muscle is giving the higher load. Look here, the load is increasing, but heart has to spend much more energy, spend much more exponential energy. Look here, exponential energy. So one time will come, due to continuously working against this higher or highest load, the muscle fiber will be damaged. The muscle fiber will be damaged. How the muscle fiber will be damaged? There are lots of mechanisms. How the muscle fiber will be damaged? There are lots of mechanisms. First point, this muscle requires more oxygen or less oxygen in this pathological condition. This muscle requires more oxygen or less oxygen. Less oxygen. So more oxygen. Extreme. This muscle requires more oxygen in this pathological condition. Suppose my cap is very tight. So when I am trying to open my when I am trying to open my cap, I have to give extra energy, and those extra energy will be come from my extra ATP, and those extra ATP will be generated in presence of extra oxygen and extra nutrition. So that's why to work against a very much load, very high load, very massive load, I demand more oxygen. So the heart requires more oxygen. But due to low cardiac output, the blood supply to the heart is low. Due to low cardiac output, the blood supply of the heart is low. So your demand is high, but supply is low. So when there is demand is high and supply is low, normally your heart muscle will not get enough oxygen. So there is oxygen deficiency and also nutrition deficiency, because your blood transports both oxygen and nutrition. So oxygen and nutrition deficiency will be there. So normally when there is oxygen and nutrition deficiency will be there, that condition is called ischemia. So your muscle is suffering from the ischemic injury. When muscle is suffering from the ischemic injury, heart muscle is suffering from the ischemic injury, so damage will be there. And when there is some damage, the body's automatic response to repair that damage. Suppose there is some injury onto my hand, the body's automatic response to repair my hand. And what is the normal or natural repairing process? To deposit the fiber. That is called fibrosis. So in this case, the heart muscle will be more fibrosed, or fibrosis will be there. Fibrosis. And fibrosis basically occurs when there is injury, when there is chronic damage. This fibrosis means fibroblast cell will be proliferated into mature fibrocyte, and those fibrocyte will lay down the mature fiber. So this fibrosis mainly occurs due to the activation I'm just clearing this part. Activation of fibroblast and their proliferation and maturation. But when there is fiber deposition, the muscle loses its flexibility, the muscle loses its working capacity. Suppose my finger, I am nodding my finger, and when there is tough fiber will be there, I cannot nod my finger, I cannot shake my finger. So my finger function will be lost. And it's protected. But in name of protection, by in the guise of protection, fibrosis impairs the normal function, especially normal moving function, normal elastic function. Fiber hardens that structure. Second thing, when there is ever increasing strain, when there is ever increasing resistance during the pumping action and during counteracting the greater hydrostatic forces, normally the heart muscle cell will remodulate. The heart muscle cell will remodulate. What is remodulation?